If you mix sodium chloride in water, it disappears. It dissolves. However, if you put oil in water, it just stays. It does not dissolve. Why is that so? Why do some things dissolve while others don't? Let's understand. Let's take sodium chloride. We have the positively charged sodium ion and the negatively charged chloride ion, held together by the electromagnetic force. Now let's introduce water. So H2O is a covalent compound with hydrogen and oxygen. So electrons are shared between these two atoms. 2 electrons from the oxygen and 1 electron each from the 2 hydrogens. So this is what H2O looks like. But remember that oxygen is electronegative. It's electronegative, which means that this oxygen wants to hog all electrons. It wants to pull all the electrons towards itself. So actually, this is not what H2O looks like, because the oxygen will pull the shared electrons towards itself. So H2O looks more like this, where the shared electrons are closer to the oxygen. So we can say that there's a little bit of negative charge on the oxygen and a little positive charge on the hydrogen. If you've watched my previous video on electronegativity, you might connect this with HCl. Okay, so now we know what H2O looks like. Let's take a whole lot of water and put some sodium chloride in it. And what do you see? The H2O molecules align in a certain way. Now this may seem very random right now, but it will make sense when we look at it one by one. Let's see sodium ion first. So here we have the sodium, and here we have all this water aligned like this. Now notice how the slightly negative oxygen of the water is attracted to the positive sodium ion. These 3 water molecules are aligned like this because the slightly negative oxygen is attracted to the sodium. So now the oxygen will be closer to the sodium. On the other hand, here we have the chloride ion, and here the water molecules will align in just the opposite way. Now the slightly positive hydrogen will be attracted to the negative chloride ion. The hydrogen will be closer to the chloride. Now you see why the water aligned in this way? Now we see there's an attractive force between these two atoms and the water. So water is now kind of glued to these atoms. But water is also a liquid. And what do liquids do? They flow. So all these water molecules will flow in random directions, and in doing so, they will pull apart the sodium and the chlorine. The salt will break. The water broke the salt into its ions. And now what do you see? All components of the salt have fit in between the molecules of water. It has fit in the spaces between the H2O molecules. So that's how stuff dissolves in water. Now let's take something that doesn't dissolve in water. Benzene. It doesn't have to be just benzene. It can be anything like oil or sand or mud. It's just that benzene was really easy to draw. So here we got the carbon and the hydrogen. And carbon really isn't an electronegative atom. Neither it's electropositive. So it does not pull or push electrons. So if you made a covalent bond with carbon, carbon would neither pull or push the shared electrons. So the shared electrons would just chill in the middle of the carbon and the hydrogen. So here, neither the carbon nor the hydrogen is charged. All parts of benzene are neutral. This is because none of the atoms hog electrons. Had this been something like oxygen or chlorine, we would see a charge difference, because these atoms hog electrons. So before we put this benzene in water, there's a last piece of information we need. How molecules of water interact with themselves. Here we have a lot of water, and these water molecules have slightly charged parts. So here also, the positive and the negative will attract. So let's see what it looks like. What do you see? The molecules align themselves, and see how the positive is facing the negative everywhere. So all these water molecules are attracted to themselves. The slightly negative oxygen is attracted to the slightly positive hydrogen. Each of the H2O molecule is kind of glued to other H2O molecules. Now if you add benzene here, it will just stay in the corner. This is because it's neutral. The charged ends of the water molecule can't be attracted to something neutral. There has to be charge in order to be attracted. There's no charge in benzene where the water can glue itself. So the water molecules just say, we don't care what you do. We are happy amongst ourselves. We don't want to interact with you. We actually couldn't care less. So the water will just stick to itself and leave the benzene alone in the corner. And this benzene will just clump up and not dissolve. So this is why some things don't dissolve in water. So now you know.